Have you ever taken the time to contemplate the architecture of the supercluster of galaxies in which we live? We live on Earth. Earth is the third planet from the Sun. It belongs to the solar system. The solar system lies within the Milky Way, which in turn lies within the Local Group, which contains over 50 galaxies and extends over some 10 million light-years. The Local Group lies on the periphery of the Virgo Cluster, a cluster containing over 1,000 galaxies, 60 million light-years away. It represents a small part of the Local Supercluster, a region around 100 million light-years across containing several hundred galaxy clusters. A galaxy is a vast collection of gravitationally-bound stars, dust, and interstellar gas. Galaxies come in all shapes and sizes, from 2,000 to 500,000 light-years in diameter. Until recently, the Local Supercluster was considered the last line of our cosmic address. But today we know that we belong to a collection of several galaxy clusters that are gravitationally linked to each other. Laniakea is the supercluster in which our own Milky Way galaxy, along with thousands of other galaxies, lies, stretching over a diameter of around 520 million light-years. How can we go from a simple grouping of stars to a gigantic structure over 500 million light-years in diameter? And what does this Laniakea supercluster look like? Dear traveler, welcome. Today we're off to explore the farthest reaches of our universe to discover the Laniakea supercluster. But before you set off on your next adventure, be sure to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a nice trip. We take you on a journey through Laniakea. After the Big Bang, the universe was probably very uniform. At that time, there were no stars, galaxies, or any other type of structure. How did the universe go from a simple, uniform distribution of matter to a complex architecture in over 13 billion years? How did it evolve into such a spectacle of form and color? The density of the primordial universe was subject only to slight variations in homogeneity caused by the incessant movement of particles stirred up by radiation. The density perturbations that were created used gravitation. They grew in size, and the force of attraction caused by their own mass enabled them to draw matter around them. This is how the gaps in homogeneity that still exist today were created. Theories on galaxy formation are based on two scenarios. The first scenario is based on the hierarchical theory, which implies that the first structures to form were those with a mass sound 1 million times that of the Sun. Larger structures, such as galaxies, formed by agglomerating smaller ones. These galaxies then grouped into clusters, leading to even larger structures, superclusters, which are linked by the force of gravity. Another theory holds that conversely, the smallest structures are the result of the fragmentation of the largest. In this sense, superclusters would have been created in the first instance. Millions of billions of solar masses would have collapsed under the pressure of gas and radiation. The masses of this entity would then have occupied immense spaces, The expansion of the universe, initiated by the Big Bang, would have forced the great structure and formation to flatten, producing a sheet of dense matter. This sheet then contracted, giving rise to filaments stretching over millions of light years. Over time, these would divide into smaller entities, forming galactic clusters, and then simple galaxies. Over the past few decades, observations of the youngest galaxies have provided further support for both theories. Although there are arguments in favor of both the fragmentation theory and the hierarchical theory, the origin of galaxies is still an open chapter. Galaxies are defined as systems composed of dust, gas, and an astronomical number of stars, all held together by gravity. Most large galaxies also have supermassive black holes at their centers. In 1936, Hubble established a classification of galaxies into 4 types: spiral, elliptical, lenticular, and irregular. Spiral galaxies take the form of a flat disk rotating around a central bulge surrounded by spiral arms. The rotating motion, which can reach speeds of several hundred kilometers per second or miles per second, causes the matter in the disk to take on a particular helical shape. Our galaxy, the Milky Way, is a spiral galaxy. This type of galaxy contains old stars, gas, dust, and young stars. They are generally surrounded by a massive halo of much sparser stars. Elliptical galaxies appear as large, more or less elongated balls of relatively old stars. They therefore appear redder than other galaxies. The space between their stars contains almost no gas, preventing the formation of new generations of stars. Lenticular galaxies are a compromise between spiral and elliptical galaxies. Like spiral galaxies, they consist of a relatively thin disk, rotating around a central bulge, but they have no spiral arms. Like elliptical galaxies, they contain little dust and interstellar matter. Irregular galaxies include original galaxies with very particular shapes that don't fit into any of the other categories. They can resemble twisted disks or distorted balls. Anything seems possible. NGC 4214 is a small irregular galaxy in the Hound Dog constellation, around 13 million light-years away. One of its features, and perhaps the most attractive, is its enormous heart-shaped cavity. Inside it is a gigantic open cluster containing young stars with surface temperatures ranging from 10,000 to 50,000 degrees Celsius, or 18,000 to 90,000 degrees Fahrenheit. This cavity is thought to have formed as a result of stellar winds, and the resulting absence of gas has put a brake on star formation in this area. Galaxies are not isolated in the universe. They move in relation to one another. Sometimes they can pass so close to each other that they cause deformations, shocks, or even absorptions. Even within a galaxy, stars are born and then die, making way for new generations of stars that are very different from the previous ones. The color, brightness, and shape of galaxies are constantly evolving. Galaxies are in perpetual motion. They turn on themselves, move through space, and sometimes collide if they're too close to a neighboring galaxy. When two galaxies cross paths, the more massive one can attract the gas, dust, and stars of the smaller one. As a result, the larger galaxy grows, taking advantage of the smaller galaxy's components to form new generations of stars. The smaller galaxy is then greatly distorted. Sometimes galaxy encounters cause accelerated concentration of gas clouds, leading to outbreaks of star formation. In other cases, a giant galaxy may swallow up a smaller one. The stars and interstellar medium of the smaller galaxy mix with the components of the giant galaxy, resulting in a diverse population of stars. This is known as galactic cannibalism. When galaxies group together in hundreds or even thousands, confined to a spherical space whose evolution is not yet complete, we speak of galactic clusters. These are the largest organized structures in the observable universe. Galactic clusters are structures so large that their construction phase is not yet complete, and they have not yet reached a stable configuration. This means that some objects have not yet reached their point of dynamic equilibrium. Astronomers have thus classified clusters according to their possible evolutionary scenario. There are irregular clusters, generally the youngest, and regular clusters, generally the oldest, with a very high spheroidal galactic central density. In astronomy, different clusters have been identified by their size. These variable dimensions are measured in terms of the cluster's very richness, i.e., its content of bright galaxies over a defined distance of 1.5 megaparsecs from the center. Remember that 1 parsec is equal to 3.26 light-years. The richest clusters are the rarest. Based on this classification, the average distance calculated between two clusters is 42 megaparsecs, whatever the cluster, even for the poorest. On the other hand, to go from one super-rich cluster to another, you need to travel an average distance of 188 megaparsecs. The richness of a cluster determines the type of galaxy it contains. Rich clusters contain a majority of elliptical galaxies. This is because greater richness implies greater galactic density in the inner zones of the cluster. As a result, the richest clusters are generally the most regular. Given that the most regular are also the oldest, galaxies naturally tend to change shape from spiral to elliptical or lenticular. This phenomenon affects the most distant clusters with a large number of blue-colored galaxies, typical of spiral galaxies. The Hubble Space Telescope is making fantastic discoveries in the field of astronomy. Operational since 1990, it features a large mirror, enabling it to deliver images with an angular resolution of less than 0.1 arcsec. Its ability to observe in the near-infrared and ultraviolet enables it to outperform the most powerful ground-based instruments. The data collected by Hubble has contributed to some very important discoveries in the field of astrophysics. Among other things, the telescope has uncovered galactic clusters billions of light years away. These are spiral and even irregular galaxies that are no longer counted today. There are two possible explanations for their disappearance. Firstly, the merging of two or more galaxies. When a merger occurs, gravitational interactions cause an inevitable morphological change. Computer simulations have shown that the result of a merger is always an elliptical spheroidal galaxy. The other cause of their disappearance is the cessation of new star formation within galaxies. If the gas contained within a galaxy is completely dispersed or consumed, star formation can come to a halt. On the other hand, strong gravitational interactions can cause the gas in a spiral galaxy's disk to escape, leading it to evolve into a lenticular galaxy, or into a galaxy with a disk but no more stars, taking on the colors of an elliptical galaxy. The trend towards galaxy association is not limited to the MPC scale. The local group, or group of galaxies, forms an immense structure with others in the Virgo Cluster. It's a vast flat expanse with a small central bulge, known as the Local Supercluster. A dozen superclusters are listed on the three-dimensional map of the observable universe. Among the closest are the Hydra Centaur, the Hare of Bernice, and Perseus fish. The largest visible structure in the universe is the gigantic Sloan Great Wall Cluster. This cosmic structure, forming a giant wall of galaxies, is 1.38 billion light-years long and lies a billion light-years from us. The Great Sloan Wall is about 1/60th the diameter of the observable universe. It contains several superclusters of galaxies. The superstructure of the cosmos that interests us today is none other than the supercluster of galaxies that shelters us. Its name is Laniakea. Laniakea is a supercluster of galaxies comprising a set of three superclusters converging at a speed of around 6.30 by 10 to the 5th power miles per second in the direction of the Great Attractor. It is one of 6 million superclusters in the observable universe. It represents around 4% of the diameter of the observable universe, due to its approximate size of 520 million light-years. Laniakea contains three superclusters: the Virgo Supercluster, to which our planet Earth and the Milky Way belong, the Hydra Centaur Supercluster, home to the Great Attractor, and the Peacock Indian Supercluster. The Indian Peacock Supercluster is located more than 210 million light-years from Earth in the Peacock constellation. It is made up of several thousand galaxies, some of which are very well known and important. The three main clusters are Abell 3656, Abell 3698, the densest, and Abell 3742. It incorporates a nearby galaxy wall, linking the Ruler Cluster to the Centaur Supercluster. A galaxy wall defines a galactic filament made up of a set of galaxies forming a boundary between cosmic voids, which together make up the cosmic web. The Indian Peacock Supercluster contains no rich galactic clusters, nor any particularly large concentrations of galaxies. It is therefore not considered a major component of Laniakea. In the sky, it is faintly discernible as a curved wall of galaxies, linking the A3627 or Ruler Cluster and the Centaur Supercluster. The Hydra Centaurus supercluster is one of the largest known galaxy superclusters, covering an area of several tens of millions of light-years. It contains many important celestial objects. It is the nearest neighbor of our own Virgo supercluster. The supercluster is divided into several parts. The Centaur supercluster, which includes the Centaur cluster, the Hydra supercluster, which mainly contains the Hydra cluster, and the Ruler cluster. These clusters lie between 150 and 200 million light-years apart. Other, smaller clusters complete the picture. One of the features of the Hydra Centaur supercluster is its proximity to the Great Attractor. The latter is a gravitational anomaly in intergalactic space at the center of the Laniakea supercluster. The Virgo supercluster, also known as the Local Supercluster, is a supercluster of galaxies to which the Local Group, comprising the Milky Way and Andromeda Galaxies, belongs. It owes its name to the Virgo Cluster at its center. Its diameter is around 200 million light-years. The Virgo supercluster consists of a disk and a halo. The disk is circular in shape and contains 60% of the supercluster's luminous galaxies. The halo, on the other hand, is made up mainly of elongated objects and contains the remaining 40%. Within the Virgo supercluster, there are some 10,000 galaxies and over 100 clusters. The Virgo cluster is located close to its center, while the Local Group is close to the edge, but attracted by it. Its total mass is estimated at around 10 to the 15th power solar masses. As its luminosity is relatively low compared with the number of stars it contains, scientists agree that a large proportion of it must be made up of dark matter. All the objects in the Virgo supercluster are gravitationally attracted to the Great Attractor. The Virgo supercluster is unbundled into clusters called clouds of galaxies. The disk contains the Virgo cluster, the Hound cloud, and the Virgo II cloud. In 1964, two Americans accidentally discovered a form of radiation in which the entire universe is immersed, the cosmic microwave background. It was then that they discovered that our galaxy was moving at an astronomical speed of 630 kilometers per second, or 390 miles per second. At the time, the phenomenon was not fully explained, and teams of astronomers were formed to investigate it further. The Seven Samurai, a team of 7 American astronomers, supported and studied this shift. After 20 years of research, they succeeded in measuring the speed of displacement on a sample of around 400 galaxies. They also succeeded in delineating the zone that seems to be attracting our galaxy. However, the latter is occulted by our own galaxy. The stars forming a luminous band on the celestial vault mask precisely the location that interests the scientists. Scientists agree that our galaxy is not alone in moving at 630 kilometers per second or 390 miles per second, but that all the galaxies around us are moving in the same direction through the cosmos. The Seven Samurai couldn't explain this phenomenon with the physics of the time, so they came up with a model. It would be a gigantic obscure mass, invisible to us but attracting us. This enormous mass is known as the Great Attractor. Although telescopes at the time were not powerful enough to observe it, resources were deployed to improve observation tools and succeed in discovering this curious Great Attractor. In 2014, researchers discovered that we belong to an even larger structure. While trying to map the direction in which thousands of galaxies are moving, researchers discovered that the Local Group is part of the Laniakea Supercluster. The Local Supercluster is, after all, only a lobe of a supercluster comprising 100,000 large galaxies and extending over a distance 10 times greater. Scientists discover that the Great Attractor is not simply a huge spherical obscure object, but the central point of a celestial continent towards which objects are gravitationally directed. All this represents only 4% of the mapped universe. The newly discovered gigantic supercluster is named Laniakea in honor of the early Polynesians who explored the Pacific Ocean using the stars as a guide. Laniakea means immense celestial horizon in the Hawaiian language. It measures over 520 million light-years in diameter. It is surrounded by other superclusters such as Shapley, Hercules, and Perseus Pisces. Within Laniakea itself, different forces influence the movement of galaxies. Thanks to the discovery of Laniakea, we are learning more about the architecture, dynamics, past and future of the universe. The distribution of galaxies and their movements give us valuable information about the history of their formation. Within the borders of Laniakea are a multitude of small and large galaxies with a mass equivalent to 100 million billion times the mass of the Sun. The supercluster of galaxies in which we live is immense and could be defined as follows. Take our galaxy, multiply it by 100,000, add 1 million smaller galaxies, and you get Laniakea. We begin our journey in the direction of the one that lies at the center of Laniakea and has the greatest influence on its members. This is the Great Attractor. As early as the 1970s, the first signs of a deviation from what is supposed to be a uniform expansion of the universe were detected. In 1986, the position of the so-called Great Attractor was defined. This is a gravitational anomaly at the center of Laniakea, in the vicinity of the Hydra-Centaur supercluster. It is difficult to observe because it lies directly behind the galactic plane of the Milky Way. The Great Attractor can be detected indirectly through its effect on the motion of galaxies and clusters. The expansion of the universe explains why galaxies are constantly moving further apart. However, huge clumps of matter can slow down this movement. Over the past billions of years, our galaxy, and all the galaxies around us, have moved closer to the Great Attractor. There are several theories about the nature of the Great Attractor. It could, for example, be caused by an overdensity of matter. The Great Attractor remains a mystery. It lies on the other side of the Milky Way, with an enormous number of stars and star clusters positioned between them and us. Added to this is a jumble of gas and dust. The light that is supposed to reach us is consequently obscured, making it difficult for scientists to observe. The only certainties are that our galaxy, and everything in our supercluster, is heading towards the Great Attractor. Does this put our planet at risk? no one really knows at present. While some astronomers don't see it as a problem, others think that galaxies and all the clusters could coalesce into ever larger superclusters, eventually causing the end of the universe in the form of a big crunch. Let's continue our journey in our closest neighborhood, astronomically speaking, since we're talking about visiting distances of the order of thousands of light years. The Milky Way, our own galaxy, is the one we know most about in detail. Studying it enables us to better understand the world around us and the parts of the universe to which we have no access. We live on Earth. Our planet lies close to the Sun, which in turn lies on one of the arms of our spiral galaxy called the Milky Way. The Earth is launched into its orbit at around 30 kilometers per second or 19 miles per second around the Sun. The Sun drags the entire solar system along at a speed close to 220 kilometers per second or 136 miles per second. Although these speeds seem dizzying, the Milky Way is so vast that we're only about half the length of the arm. If we were to compare the Earth to a marble 1 millimeter in diameter, the Moon would be 3 centimeters or 1 inch away. The Sun would be 1.5 meters or 5 feet away, and the nearest star 3,200 kilometers or 2,000 miles. The Milky Way would then have a diameter extending to half the distance separating us from the Sun. The Earth is infinitely tiny in this system that surrounds it. Over the past few centuries, mankind has become increasingly aware of the immensity of the stellar world and has been scrutinizing it ever more closely, mostly from a distance. Seen from Earth, the spectacle of the Milky Way is awe-inspiring, even without any instruments, especially when you're in the southern hemisphere, as the luminous regions of the galactic center shine high in the sky. The Milky Way remains one of the most important targets in the exploration of the universe. Although the distances are gigantic, it provides us with an accessible laboratory of the universe, where a panoply of objects representative of the stars and other celestial objects that populate our galaxy can be found up close. Within the Milky Way, elementary physical processes are also taking place that can be analyzed. Scientists agree that the Milky Way is a representative prototype of the spiral galaxies that make up the largest class of galaxies today. Exploring the Milky Way, therefore, provides us with elements to explain this type of galaxy throughout the universe. What's more, man's origins are rooted in the Milky Way. It is like our cosmic habitat in which our solar system was formed. The Milky Way is a spiral galaxy with a diameter of 100,000 light-years and a thickness of just over 1,000 light-years. It was formed billions of years ago, when an immense cloud of gas collapsed under its own gravity and flattened under the effect of rotation. It consists of a central bulge, around which 2 main spiral arms and segments of other arms are articulated. Their shape is shaped by bright young stars, gas and dust nebulae, and dense dark molecular clouds. The central bulge contains many old stars but little gas. The Milky Way is roughly the shape of a very thin disk. It contains between 200 and 400 billion stars. Although this figure seems extraordinary, the total mass of stars occupies only a tiny total volume on the scale of that of the galaxy. Stars are scattered all over the galaxy's great void, but this vacuum of space is occupied by extremely tenuous interstellar gas. Galaxies are made up of stars, dark matter, various exotic components, and interstellar gas, which is diluted in this gigantic volume between each star. Interstellar gas is extremely dilute, containing an average of 1 atom per cubic centimeter. Compared to the air we breathe, this is more than 10 billion times less. It is from this interstellar gas that new stars are formed. Proto-galaxies were initially nothing but gas. Then, over billions of years, galaxies like the Milky Way expanded by accreting gas from outside the galaxy. It was interstellar gas that gave spiral galaxies their disk shape. A ball of gas can be compressed along its axis of rotation by its own gravity. A disk forms perpendicular to this axis. Interstellar gas can be cold atomic, hot atomic, molecular, hot ionized, or very hot ionized. Cold atomic gas accounts for about half of its total mass. It is an indispensable reservoir that feeds the molecular clouds in which new stars are formed. Molecular gas is the natural state of most gases, neither too hot nor too dilute. Interstellar molecular gas accounts for roughly 1/3 of the total mass of gas in the Milky Way. It is not homogeneous and is scattered with lumps. These small, dense clouds are ideal sites for the formation of new stars. The density and temperature conditions of interstellar gas lead to the presence of some quite extraordinary molecules. These highly reactive species, which are fleeting in our laboratories, play a key role in the chemistry of the interstellar medium. They are created by reactions initiated by cosmic rays or ultraviolet radiation. A galaxy like the Milky Way is largely composed of a gas in which all hydrogen atoms are ionized. Each star is surrounded by a bubble of denser gas, ionized directly by ultraviolet photons. The distribution of stars in interstellar gas is totally dominated by the disk structure, but the importance of peripheral regions should not be underestimated. Gas in stars can extend far into the exterior of the disk. A spherical region, called the galactic halo, contains one of the oldest stellar populations in the galaxy, as well as mysterious dark matter. The central region of the galaxy stands out for its originality. The bar shapes the structure of the central disk, enabling it to be fed with gas, and thus support dynamic star-forming activity. The bulge of the galactic bulge bears witness to earlier star formation in these regions. A large black hole of several million solar masses remains at its center. This supermassive black hole at the center of the Milky Way remains modest in comparison with the black holes at the center of giant elliptical galaxies. Despite its mass of 4.2 million solar masses, it remained unknown until 1974. This Milky Way black hole remains dormant due to the lack of accretion of large quantities of gas, so its environment emits only modest energy. Since its discovery, scientists have been wondering whether this black hole is likely to wake up in the not-too-distant future and become an active galactic nucleus. The stability of the Milky Way would seem to give us peace of mind for the next few 100 million years. However, gas accretions can occur regularly, gradually increasing the power of this radio source. The galactic center is therefore closely monitored. The interstellar medium is made up of dust composed mainly of silicate or graphitic carbon. They range in size from a few micrometers to a few nanometers. They absorb UV radiation, protecting the molecules inside molecular clouds. The dust is constantly exchanging molecules and atoms with interstellar gas. Supernova explosions have a significant impact on the state of the interstellar medium. The energy released at immensely high velocity greatly upsets the surrounding interstellar medium. It becomes highly ionized, full of energy, and emits a peculiar radiation at all wavelengths. This is why remnants of historic supernovas, such as the Crab Nebula, stand out against the galactic sky. As the most massive stars have relatively short lifetimes, their supernova explosions frequently occur in the environment of the giant molecular cloud in which they formed. Cosmic rays are the most energetic component, directly linked to the violence imputed to the interstellar medium by supernovas. Their energy is sufficient to penetrate to the heart of molecular clouds, where they are a source of gas, heating, and the origin of all interstellar chemistry. The interstellar medium is marked by the universal action of the magnetic field on moving charges. The interstellar magnetic field is on average 30,000 times weaker in the Milky Way disk than the Earth's magnetic field. Interstellar magnetic fields are generated by currents of electric charge created by a kind of natural dynamo. Even if this force is not very intense, it is able to bend the trajectories of charged particles in a spiral around the magnetic field, since it is applied over astronomical timescales. Astronomers have traced the spiral structure of our galaxy, even though it is impossible to see it from the outside. Infrared images provided by the Spitzer telescope have revealed that the Milky Way is dominated by just two arms. The galaxy was once thought to be made up of four main arms, but two of these have now been downgraded to secondary arms. The two main arms are the Centaur Arm and the Perseus Arm. They surround a central core of young and old stars. The secondary arms are the Ruler or Cygnus Arm and the Sagittarius Arm. They are mainly composed of gas and contain numerous stellar formations. Between Sagittarius and Perseus lies a small partial arm called the Orion Arm, in which our Sun is located. The Perseus Arm takes its name from its apparent proximity to the constellation Perseus. It lies between the Ruler Arm and the Sagittarius Arm. Some interesting celestial objects can be found here. The explosion of a supernova is as impressive as the appearance of a comet. Centuries ago, astronomers and astrologers recorded these strange celestial events. In July 1054, Chinese chronicles reported the appearance of a bright new star in the Taurus constellation. This star remained visible for several days, even during the day. In 1731, an English astronomer discovered a small faint nebula in the Taurus constellation. It was later nicknamed the Crab Nebula because of its shape. It lies around 6,500 light-years from Earth and has a diameter of around 10 light-years. In the early 20th century, astronomers discovered that the Crab Nebula was expanding. Thanks to backward calculations, it became clear that the moment when its expansion began coincided with the appearance of the star of 1054. The Crab Nebula represents the expanding shell of gas created by the supernova explosion seen in 1054. It continues to grow at a speed of 1,500 kilometers per second, or 930 miles per second, and will continue to dilute in space over the coming millennia. At the center of the nebula is a pulsar that rotates on itself around 30 times per second. It radiates 200,000 times more energy than the Sun. The Crab pulsar is at the origin of the nebula and responsible for its central radiation. Pulsars emit strong electromagnetic radiation, briefly and regularly, several times a second. They are formed by supernova explosions. They are fast-rotating neutron stars whose magnetic fields concentrate the radiation they emit into a fine beam. The Crab pulsar measures around 28 kilometers or 17 miles in diameter. It emits pulses every 33 milliseconds, but this frequency gradually decreases, indicating that the pulsar is slowing down. The region around the pulsar is particularly dynamic due to the energy emitted. The progenitor star is the one that exploded into a supernova and formed the nebula. It was a massive star. When the core of a massive star collapses in on itself, it congeals into an iron core. The atmosphere collapses and bounces off this core, triggering an explosion. It leaves behind an object, in the case of the Crab Nebula, a pulsar. The progenitor star had a mass of around 10 solar masses. The filamentary structures of the nebula are not visible to the naked eye, and can only be observed through a telescope. The Centaur arm lies between the Sagittarius arm and the Ruler arm. It is also known as the Echo-Croy arm. The section of the arm begins near the galactic center and forms the Echo arm. It becomes the cross arm as it moves away from the center. In 2007, a cluster containing around 50,000 newly formed stars was discovered in an area of the Centaur arm. The cluster is less than 20 million years old. Within it, 26 supergiants have been identified, making it the largest grouping of such stars. The Ruler arm is named after its proximity to the Ruler constellation on the celestial sphere. Its source is at the end of the central bar, not in the surrounding region. The Ruler arm is defined by the part of the arm that is close to the galactic center. The outermost parts of the arm are called the Swan Arm. For this reason, it is often referred to as the Ruler-Swan Arm. The Sagittarius arm is one of the two longest in the galaxy, along with the Ruler arm. Its end, closest to the bar, is connected to the end of the bar itself. The Sagittarius arm is rather dense. It lies between the Centaur arm and the Orion arm, close to the constellation Sagittarius. The part of the arm that emerges from the central bar is called the Sagittarius arm, while the outermost part is called the Carina arm. Several stellar objects are visible in the Sagittarius arm. The Lagoon Nebula, also known as M8, is located around 4,000 light-years away, at a point in the Sagittarius constellation where this type of object is found in large numbers. That is, in fact, the richest region of the Milky Way, as it faces the center of the galaxy. Dust clouds are almost always found on the galactic plane. The Lagoon Nebula is associated with an open cluster. Nebulae, which are star-forming zones, are often accompanied by clusters of young, brightly scintillating stars. Within this open cluster are some 40 stars with magnitudes between 8 and 13. This brightness excites the nebula's atoms, making it visible. Also visible within M8 are various Bok globules, dark clouds of dense gas and dust where stars form. The Trifid Nebula, also known as M20, owes its name to its characteristic three-part shape. It is thought to be around 4,000 light-years away. With binoculars, the bright part of the nebula can be seen perfectly, in the shape of a round spot. The darker parts that divide the nebula into flaps are caused by the presence of dust and cold gas. M16, the Eagle Nebula, lies at the edge of the Shield constellation, close to the Serpent constellation. Its distance is estimated at around 5,000 light-years. Within the nebula itself is a dark region that stretches from the north towards the center of the nebula. The associated cluster consists of several dozen stars, some of which are faintly visible and red. Although this is a nebula in emission, it has some reflective features. M11, the Wild Duck Cluster, is the richest open cluster in the sky. It comprises almost 3,000 members and is located just over 6,000 light-years away. The cluster is so crowded that the distance between stars towards the center of the object is tens of times smaller than the average distance in the Milky Way. Its stars are relatively young, between 200 and 250 million years old. Viewed from Earth through a telescope, the stars appear to be arranged in a V-shape, so much so that this magnificent cluster has been likened to a flight of wild ducks, hence its name. The Omega Nebula, also known as M17, is one of the most contrasting diffuse objects in the sky. With the aid of binoculars, you can identify its central spindle-shaped region, which gleams not far from a beautiful orange star. The luminous curves of this nebula suggest that it is made up of exceptional quantities of gas. And yet, the mass of this nebula is equivalent to less than 1,000 suns. Nonetheless, it remains one of the most imposing nebulae in the Milky Way, extending over almost 50 light-years. The Omega Nebula is the birthplace of one of the youngest star clusters known, less than 1 million years old. The cluster contains some 35 stars at most, but the total number of stars in the nebula is around 1,000. It's one of the most fertile star nurseries in the Milky Way. The Orion Arm is a minor arm of the Milky Way. It is in this arm that the solar system, and therefore the Earth, is located, close to the lower edge some 26,000 light-years from the galactic center. The Orion Arm lies close to the constellation Orion, between the Sagittarius Arm and the Perseus Arm. It is estimated to be 10,000 light-years long and 3,500 light-years wide. The Orion Arm contains several recognized objects. The Orion Nebula, named M42, is the closest to Earth at 1,300 light-years. This diffuse nebula is home to numerous star-forming stars and even planetary disks. The Orion Nebula is visible through binoculars as a small cloud amid the stars of Orion's sword. It glows fluorescently. Ultraviolet radiation from bright stars excites gas atoms, which in turn emit light. The color emitted differs according to the type of atom. Hydrogen and sulfur emit mainly red light. Oxygen glows green. Although our eyes can't distinguish colors very well at night, and all nebulae generally appear gray to the telescope, the Orion Nebula is an exception to the rule. The Orion Nebula is an exception to the rule and makes it easy to observe the different colors of a nebula. Also known as M45, the Pleiades cluster has been known since Neolithic times. Its appearance in the morning sky heralded the harvest season. It is located 440 light-years from Earth, and although only a small number of stars are visible to the naked eye, this open cluster contains several thousand. The Pleiades cluster is 100 million years old. In 200 to 300 million years' time, it is likely to be completely dispersed in the Milky Way due to its low density. The origin of the name Pleiades comes from Greek mythology. Children of Atlas and Pleione, the Pleiades are 7 sisters. Their names and those of their parents were given to the 9 brightest stars in the cluster. The best-known planetary nebula is the Lyra Nebula, known as M57. It is located in the constellation Lyra and is difficult to identify due to its low surface brightness. It lies around 2,300 light-years from Earth and is between 3,000 and 6,000 years old. The name planetary nebula comes from the fact that early observers mistook these objects for planets due to their circular shape. In reality, they are formed by the emission of a gas envelope from stars at an advanced age in their evolution. Its characteristic shape has also earned it the nickname Ring Nebula. The inner region of the ring emits ultraviolet rays, making it appear darker. The central regions emit blue-green hues from doubly ionized oxygen. The outer regions of the ring appear red. The central star is a white dwarf, slightly larger than the Sun, with an apparent magnitude of 14.8. The Dumbbell Nebula, or M27, is located in the constellation of the Little Fox. Thanks to simple, small amateur telescopes, it's possible to make out its bell-shaped form. It has 2 luminous lobes. It's a bipolar-type structure that exists in other planetary nebulae, but rarely so pronounced. Planetary nebulae dilute in space at speeds of several tens of kilometers per second. As a result, they don't remain visible for more than a few thousand years. There are very few of these nebulae to be seen in the sky. The Dumbbell Nebula remains one of the largest in the sky because it is close to us, less than 1,400 light-years away, and its age means that it is widely spread out. The Owl Nebula is a planetary nebula around 2,380 light-years away. It is also known as M97. Around 6,000 years old, it is located in the Big Dipper constellation. Its name derives from its cylindrical torus shape, which appears oblique when seen from Earth. The 2 holes at the ends, which are less rich in matter, resemble the eyes of an owl. Although our own galaxy is still the one we know best, astronomy is making our neighborhood seem less alien. The Andromeda Galaxy, also known as the Great Andromeda Nebula until its true nature was recognized in the 1920s, is the largest spiral galaxy in the vicinity of the Milky Way, and the largest member of the Local Group. It is located around 2.5 million light-years from the Sun, in the direction of the northern constellation Andromeda. With a diameter of 120,000 light-years, it is twice as massive as the Milky Way. However, its dynamics and composition are similar. At its center is a compact stellar cluster with a double structure. The Andromeda Galaxy is one of the few galaxies that can be observed with the naked eye in the northern hemisphere from Earth. It is one of the largest objects in the sky, containing around 1,000 billion stars. It is thought to have formed less than 3 billion years ago, when the Earth already existed, as a result of the collision of two other galaxies. A first galaxy, already present, was struck by a second, 4 times smaller than the first, 4 billion years ago. This collision caused the two galaxies to merge, giving rise to the Andromeda Galaxy between 1.8 and 3 billion years ago. Like our own Milky Way, the Andromeda Galaxy is a giant spiral galaxy, surrounded by smaller companions. There are some 460 globular clusters associated with the Andromeda Galaxy. Myal 2, also known as G1, is the most massive and brightest of the Local Group. It contains several million stars of different generations. Around 20 dwarf galaxies orbit the Andromeda Galaxy. The most massive is the Triangulum Galaxy. M32, an elliptical dwarf galaxy still visible at the edge of the Andromeda Galaxy's disk, despite its great discretion. It seems to be the source of morphological disturbances within the Andromeda Galaxy. M33, or the Triangulum Galaxy, is the third largest object in the Local Group. It is modest in comparison to the Milky Way and Andromeda galaxies, containing just 40 billion stars. Its spiral arms are well developed and appear spectacular when seen from the front. Its immense tentacles of cold gas extend far beyond the visible disk, making it difficult to give a precise value for the Triangulum Galaxy's diameter. Its distance from Earth is also uncertain, estimated at between 2.5 and 3 million light-years. In the end, it would appear to be only slightly further away from us than the Andromeda Galaxy, even if it looks much more distant to the naked eye. Along its arms are numerous regions of ionized gas, a prime site for star formation. The largest of these nebulae, the Triangulum Nebula, bears the number NGC 604. It is 6,000 times brighter than the Orion Nebula and extends over 1,500 light-years. It is an emission nebula. Its gas is ionized by a cluster of massive stars inside its core. Within the Triangulum Nebula itself, some 200 stars are distributed in at least 2 clusters. The Great Dog Dwarf Galaxy is the closest known galaxy of any class to the Milky Way, since the nearest spiral galaxy is the Andromeda Galaxy. It lies 42,000 light-years from the galactic center and around 25,000 light-years from our solar system. It is home to 1 billion stars, equivalent to 1% of the Milky Way. The tidal forces of the Milky Way are currently tearing the Big Dog Galaxy apart. The center is relatively degraded, with a long filament of stars trailing behind in a ring. Located near the Eridan group, the Furnace Cluster boasts around 58 galaxies. The brightest in the cluster is NGC 1427a, an irregular galaxy. It crosses the cluster at a relative speed of around 600 kilometers per second, or 370 miles per second. The Furnace Cluster contains 4 times fewer galaxies than the Virgo Cluster, but is around twice as dense. NGC 1427a's interaction with its surroundings favors star formation and gives the cluster its distinctive arcuate shape. The Eridan cluster is a cluster of galaxies whose center lies around 75 million light-years from Earth. It is located in the Eridan constellation. It contains around 200 galaxies, with approximately 30% elliptical or lenticular galaxies and 70% spiral or irregular galaxies. This barred spiral galaxy is located around 69 million light-years from Earth. It is known for its luminous center and well-developed spiral arm structure. Indeed, most star bars remain imperceptible, as is the case with our own Milky Way. But NGC 1300's star bar is spectacular. This bar also plays a significant role in the evolution of the galaxy, as it increases star formation within it. The core of NGC 1300 itself has a small spiral winding extending over some 3,300 light-years. This phenomenon is due to the fact that this spiral galaxy has an imposing central bar. Located around 65 million light-years from Earth, this spiral galaxy is remarkable for its clearly visible disk with spiral arms and central bar. It is known as a grand spiral galaxy. Its spiral arms extend clearly around the galaxy and can be seen at a good distance around the nucleus. NGC 1232 is located in the Eridan constellation. This is one of the most massive galaxy clusters in the Hydra-Centaur supercluster, around 220 million light-years from Earth. It contains several bright galaxies, as well as clusters of hot gas and dark matter. Its mass is around 10 to the 15th power solar masses. It is also known as the Ruler Cluster. It lies close to the Great Attractor. Although it is relatively close to us and visible, it is nevertheless located in what is known as the avoidance zone, an area close to the galactic plane of the Milky Way that is consequently difficult to observe. The cluster is thus obscured by interstellar dust. Abell 3627 is located in the Ruler constellation. This constellation, which has seen its borders modified, is not home to alpha or beta stars, which are found in neighboring asterisms. The brightest star in this constellation is Gamma 2, magnitude 4. The Ruler cluster contains 2 interesting nebulae, NGC 6164, 6165, and Shapley 1. NGC 6164-6165 refers to 2 lobes of the nebula in emission. The nebula's gas has been ejected by the star at its center. This star is the source of the nebula's energy. The star is relatively young, between 3 and 4 million years old. It is around 40 times more massive than the Sun. Shapley 1 is a planetary nebula that describes an almost perfect circle. It is located some 4,900 light-years from Earth. Its magnitude is 12.6. The white dwarf at its center has a magnitude of 14. NGC 4696 is a giant elliptical galaxy in the Centaurus Galaxy cluster, part of the Hydra Centaurus Supercluster. It is known for its active nucleus, which produces high-energy jets of matter. It is the largest galaxy in the Centaurus cluster. It is surrounded by several elliptical dwarf galaxies. Dust filaments surround the center of the immense galaxy. These wind inwards like a spiral, swirling around a possible supermassive black hole. This barred spiral galaxy is located in the constellation Centauri, some 13 million light-years from Earth. It is known as one of the brightest galaxies in the region. 2 supernovas have been discovered in NGC 4945. The supernova SN 2005AF Type 2 and SN 2011JA Type IIP. NGC 4945 is thought to belong to the Centaurus A group. This group, of at least 8 galaxies, is located in the constellation Centaurus. This is an active Seyfert-type lenticular galaxy in the Centaurus constellation, more than 200 million light-years from Earth. It is known for its active core, which produces high-energy X-rays and radio waves. Until the middle of the 20th century, scientists believed that galaxies were relatively quiet objects. In 1943, astronomer Carl Keenan Seyfert discovered the existence of astonishing phenomena inside the nuclei of certain galaxies, such as abnormally high radio wave emission, blue light emission from central areas, and luminosity variations. It has since been demonstrated that the nuclei of different types of galaxies are in fact active. Names have since been assigned to distinguish them. These include radio galaxies, Markarian galaxies, Seyfert galaxies, quasars, and BL, Lacertae objects. Today it's accepted that these are all manifestations of objects belonging to a single family, active galactic nuclei, or AGNs. The driving force behind these active galactic nuclei is a black hole with a mass of between 100 million and 1 billion solar masses. IC 4329 is the brightest galaxy in the IC 4329 galaxy group. This group has at least 25 members. It contains a large number of vast galaxies. Located around 28 million light-years from Earth, this galaxy is famous for its flattened disk shape with an obvious central bulge, resembling a Mexican hat. Although smaller than our own Milky Way, this galaxy, known as M104, is extremely massive. It is thought to contain 1,000 billion stars and over 1,000 globular clusters. From Earth, we can observe this galaxy almost in profile, as its axis of rotation is tilted 84 degrees to our line of sight. This gives us a view of the immense dust disk that divides it in two. This object is one of the most photogenic in the universe. Its diameter reaches 50,000 light-years, and its mass is equivalent to 800 billion solar masses. The diffuse light emitted by the central swelling is due to billions of ancient stars and globular clusters. The Sculptor Group is the galaxy cluster closest to the Local Group. This group of galaxies is located near the edge of the Indian Peacock Supercluster and contains several important galaxies, such as the Spiral Galaxy, NGC 253. These celestial objects are important for our understanding of the structure and evolution of the Indian Peacock Supercluster and of the universe as a whole. The Sculptor Galaxy, also known as NGC 253, is an intermediate spiral galaxy around 10 million light-years away in the Sculptor constellation. This galaxy has a high rate of incipient star formation. It is the most massive member of the Sculptor Group. Its core is believed to house a supermassive black hole with a mass equivalent to around 5 million solar masses. This galaxy is visible through binoculars when the sky is free of light pollution, as it is one of the brightest galaxies in the sky after the Andromeda Galaxy. The dwarf Sculptor Galaxy and the irregular galaxy NGC 55, although both present in the constellation Sculptor, belong to the Local Group. NGC 1316, also known as Fornax A, is a giant elliptical galaxy around 61 million light-years from Earth. It is famous for its galactic fusion activity and intense source of X-ray radiation. The Laniakea Supercluster is home to billions of stars. Among them is Sirius. Characterized by its magnitude, 1.5, Sirius is the brightest star in the sky. It shines 25 times brighter than the Sun, yet some stars shine thousands of times brighter. In fact, it's Sirius's proximity to the Sun that makes it appear so bright. It is the 5th closest star to Earth. In ancient times, Sirius was of particular importance, since its return to the sky at dawn heralded the flooding of the Nile, crucial for agriculture. Canopus is a supergiant star 71 times larger than the Sun. It lies around 310 light-years away. It is the brightest star in the constellation Carina, and the second brightest in the night sky after Sirius. Its magnitude is 0.74. Not massive enough to eventually evolve into a supernova, it is likely to become a white dwarf. "200 billion stars populate the Milky Way, but only those not far from the solar system can be seen with the naked eye. The closest is Alpha Centauri. It's a complex star made up of 3 stars. The 2 largest form a beautiful double star, 4.37 light-years from the solar system. Their size and color are similar to those of the Sun. They are accompanied by Proxima Centauri, a faint, tiny star, barely 1.5 times the size of Jupiter. It lies closer to us than the other 2, at 4.22 light-years. Proxima Centauri holds the record for proximity to the Sun. Located in the Lyra constellation, Vega is the brightest star in this group. Observed from Earth, it is the 5th brightest star in the sky. It is relatively close to the Sun, just over 25 light-years away. Because of its high luminosity, Vega has been the subject of numerous studies by astronomers and has played a major role in astronomical discoveries. For example, it was the first star outside the Sun to be photographed and its spectrum measured. It has a disk of dust centered on the star, probably the result of collisions between objects in a debris disk, similar to the solar system's Kuiper belt. In the Orion constellation, a variable red supergiant star known as Betelgeuse shines brightly. It lies approximately 500 light-years away. It is one of the largest stars known. If positioned at the center of the solar system, its radius would stretch between the orbits of Mars and Jupiter. It used to be considered the 8th brightest star in the sky, but in 2019, a drop in its brightness pushed it down to 21st place. One explanation for this phenomenon was the formation of dust in front of the star, following the ejection of a large quantity of gas. In subsequent years, the star's luminosity increased again, reaching almost 87% of its original brightness. Betelgeuse radiates more than 100,000 suns combined. Eventually, it will explode into a supernova, which can easily be observed from Earth in broad daylight. To us, Laniakea is an immense cosmic structure in the observable universe, encompassing our own Milky Way galaxy, as well as thousands of other galaxies. Spanning some 520 million light-years in diameter, it is one of the largest known structures in the universe. Yet Laniakea is only a small part of the observable universe, which contains billions of similar superclusters, as well as regions of intergalactic void. The discovery of Laniakea has enabled scientists to better understand the large-scale structure of the universe and its evolution, as well as our galaxy's place in this vast expanse of space. Yet this journey remains incomplete, with many secrets and mysteries yet to be discovered. A century ago, the 100,000 light-year diameter of the Milky Way represented the cosmic horizon, and from our vantage point on Earth, we already felt infinitely small. Since then, discoveries have continued to push back this limit. This exploration of the cosmos amplifies our vertigo in the face of the abyss into which we are plunged.